So hello, everyone. I'm joining you live today from my office. I retrofitted my closet into an office, and I'm in Boston, where it's a dark and stormy morning. So I'm here to talk to you today about becoming a green developer. I really enjoyed the last talk by the last speaker, and this in a way builds on that idea that she had at the end of her talk of, maybe we could create a tool that would help us to make green decisions on when to do things. For example, when to train your fancy and very accurate machine learning model. So let's go ahead and get started. My name is Jen Looper. I'm a cloud developer advocate at Microsoft. So I'm happy to be here. So what's on the agenda today? Today we're going to learn about sustainable software development, and then we're going to all code together. So I hope you're excited. I love coding together. It's super fun. All right. So what is sustainable software development? Well, it's an emerging discipline at the intersection of climate science, at best practices of software development and software architecture, at figuring out how electricity markets work and how all of this applies to your profession as a software developer, to figuring out how hardware and data center design all fits into this puzzle that we're trying to figure out. And I would just refer you to a website you've probably already visited. My colleague Asim is in charge of this website. It's called principles.green. Take a good look at it. There are 8 principles that you can follow to become a little bit more green in your profession as a software developer. So the goals of this talk is to shed light on how we can follow certain recommendations to become that sustainable software engineer, and how you can make specific green decisions that can have this nice and meaningful impact on the carbon impact of your applications. And once again, check principles.green for these 8 recommendations. I don't have time to go over each one of them, but a couple of things that we're going to do today touch on some of those recommendations. So when I was working on this talk, I was trying to just ask myself this question: is it possible to build a carbon-friendly app? We're engineers. I'm American. I don't really ascribe to the Silicon Valley mantra that we can engineer ourselves out of everything, but it is this kind of idea that we as builders, we can build something that will make things better. But sometimes I just wonder, should we be doing that? Should we be building that fresh greenfielded website? Should we launch that extra mobile app that will help us, make greener decisions? Should we build a desktop app? What's the activity that we should actually be focusing on? And the problem I kept kind of bumping my head into was that, building fresh web assets that are always online consume unnecessary energy to keep them live. And I was trying to figure out some solutions to this. What about something like cloud hosting that can help you spin up assets when they're requested and they're needed? Or you could go for an offline first strategy that can keep energy requests low. I work for Microsoft, so we have our cloud solution, Azure, and other clouds that allow you to, spin up things and spin them down when you're not needing them. So that's very helpful. But maybe there's even a better solution for some of our use cases. Not every use case, but maybe some of our use cases. And the solution I kind of stumbled upon was that, what if we just build something that's hosted locally? We're just going to build this for ourselves. And by doing that, it can answer several principles. And some of it can answer 4 of the 8 principles, which I kind of outlined here. So it could answer this idea that, maybe we could build applications that are carbon efficient, and we can build an application that's energy efficient, just by the architecture of the application. We could reduce the amount of data and the distance it must travel across the network by not building something that's online all the time, and by not building something that's pinging constantly to check for fresh data. And then this idea that instead of shaping supply to meet demand, we might try shaping demand to match the supply. So this extension that we're going to build, spoiler alert, we're going to build a browser extension, can help you, especially with number 7 here. Instead of shaping the supply to meet the demand, we're going to kind of figure out what our demand is and how it might match the supply of energy that's out there. So, something kind of fun to try. Okay, so we decided we're going to build a green browser extension. Well, what the heck's a green browser extension? It can do 4 things. So this browser extension is going to help you make educated decisions to manage your personal energy usage choices. So it's going to say, okay, I live in this region. This is the carbon intensity of my current region's usage. This is what's going on in my region. And maybe I can figure out, what the task is that I need to do. And then I can figure out whether it's a good time or a good moment to do that task. This extension is hosted locally. It's just a little extension in your browser that's looking at your locally built app. And we're calling it ad hoc. So we're not, you could make it so that it would be ping constantly to check an API, to check on the carbon intensity of your region. But I figured, well, I really don't care at 1 in the morning, I'm sleeping. So why don't we just do it so that we call it ad hoc and get our reading and then make the decision that we need to make at that time. And then I decided we'll just build with vanilla JavaScript. So there's no framework overhead. There's nothing on top really that's going on. It's a very simple little app, simple but powerful. That's what we're going for. Now, when I was getting excited about browser extensions, my colleague said, hold on, not all browser extensions are created equal. And he gave me a nice screenshot here of an Edge extension here that is just crushing his machine because I think it's a password manager and it's pinging constantly. There's that problem again, and there must be some kind of memory leak going on. So he always has trouble with this extension sucking up a lot of juice. So that's not the extension we're going to build. We're going to build something a little bit simpler and a little bit less pingy. So this is something that the previous speaker said, which is a luxurious point of view, but in this case, it's valid that the greenest app is actually the one you don't build and the one you don't particularly, post into production, but just something you build for yourself to help yourself make green decisions. This is what we're going to build. This is what it looks like. It's our little browser extension. It works in Edge, Chrome, Firefox, and I cannot figure out how to add a browser extension into Safari, but I'm going to guess that if you can figure it out, it will work. Ping me on Twitter at Jen Looper if you can make Safari behave itself. So this is what it looks like. And what you're going to do is you're going to input your region's code and your API key, and you're going to get a reading. And then there's the little dot here at the top that shows you the reading of your region, and the color will change according to the carbon intensity of your region. So the API that we're going to use to query is the Co2 Signal Api, and it changes the color of the icon, like I said, based on the carbon intensity in your region. So green is better than red, for example, which you can see. I'll do the demo in just a second, but you can see New England is always a little bit yellow and red. I don't know what's going on, but now we need to educate ourselves. And then you'll be able to get a quick readout of your region's carbon status. And thus, knowledge is power. You can save power by gaining knowledge, right? Okay. So here's the demo. I'll just pop it up in Edge. Like I said, it also works in Chrome. So I've already input my region, which is US NEISO. My carbon usage is a little high, but I think what really kills us in New England is that the fossil fuel percentage, the percentage of energy, the percentage of fossil fuels used to generate the electricity is pretty high. That's not great. And it's a little surprising to me considering that we have some big wind power projects and supposedly we're a little bit more green as a region. But like I said, knowledge is power. So now we can, have some data to show our local legislatures, for example, saying, what the heck's going on and why is the wind project not happening? So lots of information that you can get from this kind of thing. Okay, so now I'd like everybody to please follow JavaScript Auntie and open your computers and navigate to this GitHub repo. It's github.com/jlooper, carbon-trigger-extension, and go to the start branch. So what I've done is I've created a couple branches. I've created main and start is incomplete, but by the end of this talk, you're going to have this complete solution. When you have that forked, make sure you're using start, and then navigate to the root and do npm I to npm install your dependencies. This is assuming that you have npm on your computer. So maybe now's not the time to reconfigure your computer for this, but if you want to take a look at this after the talk, this is how you would do it, and everything's in the README. And then take a look at the files. So we have, let me just make this a little smaller. Here's where it gets dicey because I want to show a couple things on the screen. Okay, so this is actually the main branch, which is all built. So I'll show what this is going to look like. So we have a couple folders here. We have our distribution folder, our dist folder, and that's what happens when you use Webpack to build your extension. Everything gets built into dist, but you do edit a couple files in dist, which is kind of interesting. The file that's actually built is this main.js file. So that's obviously a built file, but everything else you're going to be editing. In the source folder, that's where you're writing your main JavaScript, and this is mostly what we're going to be editing in this talk. So you have, in the dist file, you have a manifest folder, or manifest JSON file, excuse me, with some information about your extension. In source, what I was just showing you, the source folder, you have this index.js file. That's where your JavaScript code is going. And then in dist, in the dist folder, in index.html, this is your HTML markup. So this is where you saw that image and, you know, my carbon trigger. Welcome to your personal carbon trigger. In the background file here, there's some background tasks that are happening. So when icons are changed, this is all happening as a background task. I borrowed this idea from the Energy Lollipop extension, actually a nice extension if you live in California. I'm in Massachusetts. It doesn't do me any good, but very, very nice solution. And then dist and index, that's a mistake. The main.js file in dist is where everything is being built by Webpack. Okay, so what's the development process for building a browser extension? Before this talk, I had never built a browser extension. It's really fun, and I want to do more. You basically are building up a JavaScript app, and then you're using Npm Run Build to build it using Webpack, and then you add your extension to Edge. So if I open up Edge, you can see that if you click on these little dots here, you see this extensions page right here. You go there, and then you can go ahead and load unpacked any built extension that you are wanting to experiment. So this is how you develop locally and test, and you can always either remove it or reload it. You can even inspect your background page. That's really nice, and then you can always find new extensions if you decide to publish your extension, which maybe we should do. Okay, so what we're going to do is you're going to work with me on the start branch, and we're going to complete the code. But before you do that, I would like you to go to electricitymap.org and take a look at the map, how it looks. And then I want you to grab an API key for your extension. The way you do that is you go to co2signal.com. And it's kind of weird. It's like you put in your email address and then they email you an API key, but it happens pretty quickly. So go ahead and do that. Grab your API key, and then go to and all of this is on the README, by the way, of this repo. Go to the electricitymap.org API page and take a look at the zones, and you'll see which zone is closest to you. I have a couple, but I have had the best luck with USNE ISO, New England ISO. And there's plenty of zones in Europe, and you can grab yours. I know for a fact that FR is France, so I'll save you the shortcut there. And FR always is green in your icon, so good job, France. Okay. All right. Are you ready? Let's go ahead and open up our code base. So I'm going to go ahead and switch to start. And what I want you to do is follow the bouncing leaves. So the first thing we're going to do is go to source index, which is here, and we're going to look for number 1. So there's some numbers in here, and what I've done for you is I've created snippets. It's in the snippets folder, and you can just type 1 and then hit 1 and hit return, and that will give you a snippet that will just allow you to copy the code so that we're not messing up typing. So number 1 is just allowing you to check if anything is in local storage, you're going to grab that. So what we're doing is we're saving our API key and our region name in local storage. So that's the first thing. We're just going to grab that if it's available. And then what we need to do is manage the local storage inputs that are input via a form. So we're going to take a look at the setup user method, and you're going to set the user entered API key and your region. So let's look for number 2. Where's number 2? Here it is. 2 and return. So here we are setting the API key. So it's calling setup user, passing through the API key and the region name that you're entering in the form, and setting that in local storage. Your browser extension has its own little local storage. It's quite interesting. Nice little architecture. Then we're ready. Once we're set up with our local storage API key and region name, we're going to go ahead and make that initial call right here in setup user. So let's make the initial call, 3, to call display carbon usage and pass through the API key and the region name. So we'll go up to, so this is the method display carbon usage. And you can see we're passing through all the information, and we're using Axios to go ahead and query the API. All right, halfway's done. So the fourth thing we're going to do is we're going to display our usage and carbon source as it's returned from the API. So we're going to go ahead and click 4. And this is where you saw that text saying, what we're looking at. We're looking at grams of CO2 emitted per kilowatt hour and the percentage of fossil fuels that is being used. So that is your display. Once you get the response, you display the information. 5, we're going to set the icon to be generic green. We're going to start some icon manipulation. So let's go ahead and also still in source index, we're going to look for 5. Where's 5? Right here. It's in the init, which you call asynchronously. So 5. So here's where we're going to use Chrome's runtime methods to send a message. So remember, Edge is built on Chromium. So we're going to go ahead and send a message to Chrome's runtime to update its icon. And we're going to set it to green initially. Okay. And then we're going to calculate the color of the icon based on the carbon intensity. So this is number 6. So number 6. We're going to start with green, and then we're going to just calculate. So you're going to see that the browser extension will flash green, and then it will grab the actual color that it's supposed to be showing. So, red for the more carbon intense moments. So this is going to change according to the data that's brought back from response data carbon intensity. Almost done. Number 7, we're going to go ahead and look for 7, and we're going to update that icon. Where's 7? There it is. And here it's grabbing the closest color and telling the runtime in Chrome to go ahead and update that icon to the appropriate color. And those colors are sussed out and are set right here based on the value that comes back from the API. And the last thing you're going to do is you're going to navigate over to dist, background. And here's where you're going to go ahead and set that icon. So, because we're passing through to the background process, some image data, and it's going to draw the icon again according to the color that you want it to be using. And it's using the Canvas HTML API. So let's see if it worked. What we're going to do is we're going to go ahead and Npm Run Build. This is going to kick off Webpack. It's going to build my extension. Okay, looking good. Now at this point, I would go ahead and I probably for you haven't loaded this initially, so you load unpacked and grab this extension. But I can just reload it, and you see it goes back to a generic color. So here it's back to where we were. And still, we have these issues in New England. So I'm going to call my senator. So that's what's going on. So that is your carbon trigger. That's your carbon extension. Now you have the knowledge to make decisions on when you want to run the dryer, when you want to go to the store to grab a couple of things from the grocery store, and perhaps when you want to run that machine learning model if your server is in your region. Or you can switch the region based on where your server is located. So that's another thing. Okay, so we refreshed our extension, we added our API key and region name, and congratulations, now you know when to run an errand or run your dryer. So as a recap, just remember that the greenest web asset is the slimmest one, the one with the least overhead and the one that's only called ad hoc. And You just built something slim that helps you build greener, and helps you make greener decisions. And you're an awesome web developer, and I thank you very much. You can always find me on Twitter @JenLooper or on my blog at jenlooper.com. So thank you so much.